In this video, we will find the domain and range of linear equations. Pictured are primary vocabulary words that you should ensure you are familiar with. If you're not, I recommend that you look in prior notes and possibly videos online. Number 16. The total cost in dollars to buy uniforms for the players on a basketball team can be found using the function f of x equals 34.95x plus 6.25, where x is the number of uniforms bought. If there are at least 8 players, but no more than 12 players on the volleyball team, what is the domain of the function for this situation? Number 16 can be solved with a TI-30 by entering in our given formula into the table function. So let's clear out what we have, and it's 34.95x plus 6.25. Now let's press enter. Now, as you can see, I had a prior value entered. So where do we need to start? Well, we're not going to start at 0. Why are we not starting at 0? Because we are only interested in the domain that is from 8 players to 12 players. So we won't be interested in 0 at all. Okay. Now let's look at our ABCD options. For A, it starts at 0. B starts at 0. That's one reason that we won't be concerned with it. And we need to look for the range. Okay. And that being said, range will involve the y values only. So I've already stated a couple reasons to get rid of the A and then also B. There's another huge reason. A and B show values that are continuous. Our situation is discrete. That means that we do not purchase parts of a uniform for parts of players. So we need only a set distinct domain, or rather whole numbers for our domain, but we're looking for range. That means only those values and nothing in between. So it needs to be a set of values with commas, and that's what we see for C and D. Now C is giving us the actual domain. So that gets rid of C, but we need these values, and let me show you what I mean. Our table, we need to start it at 8. We will go with steps of 1 because we're not going with partial parts of the domain, whole number domain, okay? So that's why it's important to know both the domain and the range of your situation. Now I'm going to enter until we see our list. It starts at 8. What do we need? We need the value for 8, and that checks, and then 9 and 10 check, and then 2 more, 11 and 12, and they check out. So for our domain of 8, 9, 10, 11, and 12 players, those players, and the values that we need are listed correctly in D. So that verifies D using the TI-30. Since we're looking for range using the TI-84, and again, we know that range implies that we need Y values. That being said, that eliminates option A. There's also another reason why we eliminate option A. That would imply continuous information. Well, the situation is discrete because we do not purchase part of a uniform for part of a player. We have to go with whole numbers for our domain. And our domain is 8 to 10 players, okay? Well, option B is out because it does imply Y values. F of X does equal Y, but it's the wrong information. Why is it incorrect? First, it's continuous and not discrete, because we need whole players, as well as for each player, they have a unique value or cost. Also, it starts at 0. We're not starting with 0 players. We are starting with 8 players. So in order to get our range, we need our domain. Okay. Well, C is actually the domain. So that leaves us with D, but we're going to verify it. So open up your Y equals, and I'm going to clear everything out of the first one and enter our first line. And I'm going to enter our equation, 34.95 x plus 6.25. Yes, I entered it correctly. So what we need, though, is we need the table. We do not need to graph it. So let's go ahead and say second window. That sets our table. I'm going to start at 8 and just go with auto instead of using this ask function like we have in the past. Now it's entered, and I say second graph, and those are the values that we need. It just so happens that I had it preset for orange. Now we could change that color if it's a little hard to see. It's kind of tiny. So let's go back to the Y equals, and let's go with something brighter or darker maybe. So push enter and see it's on the orange. And we can just, that brown's not bad. Maybe we could see that. So let's arrow down to our OK, press enter, and now let's try second graph. There you go. That's a little bit darker. Okay, and I could see if we could slide this over. See, it doesn't make it any bigger. So hopefully you can see that it does verify option D. The first value in our Y column for 8 is correct. And then for 9 players and 10, 11, and 12. So on our TI-84, option D has been verified. On the TI-Nspire, what we need to do to enter the function to get our range, and even before we do that, we're going to enter the function in a graph. We need to remember that we are looking for Y values which associate with range. However, in order to find those, we need to know which Y values we need. And those would be from the given domain of 8 players up to 12 players. But this is discrete information. It is not continuous information. And it's discrete, and it will be for 8 players, 9 players, 10 players, 11, and 12. So we will not be starting at 0. And that information alone, the fact that it cannot be continuous and it cannot start at 0, eliminates option A and B. Now let's look at C. Well, option C would not be valid because it's actually the domain and not the range. But we're going to use it to verify that option D is the appropriate range for each of those totals. Those are total costs for 8, 9, 10, 11, and 12 players. So what do? We need to go over, and we're going to start a new document. So I arrowed over, push enter. It's always best to start out clean. And no, I do not want to save what I already had. But then I need to go up. Here, let's go over and then up. I have a digital pen that messes stuff up, which I've said before in other videos. I'll try to keep it away from that part of the calculator. Okay, so I have it set on, hey, give me a new graph. So enter. Now we're all set up to enter our function, which is 34.95x plus 6.25. Make sure that I've entered it correctly. Well, I've typed it in correctly. Now we need to enter it. Okay, that gives us a graph, but we really need a table. So we can go back to menu and then arrow down. You can use your little cursor thing or whatever you need to do. But I have it on table, and now I go over, it highlights what I need. Now I could have simply pushed number 7 also, and it would have gotten me the table and the highlight that I needed. Either way you want to do it. Then I enter, and there is my list. There's just one issue. I need to start at 8. I didn't enter restrictions. Okay. Well, that's fine. Just arrow down to 8 and only look at 8, 9, 10, 11, and 12. There's exactly what we need on the screen, and it is verified that each of these is the correct value. So option D has been verified on our Nspire. Okay, using the Desmos Graphing calculator, you can just go straight to table because the truth is we could create a graph, but from this situation, we know that it's discrete and we need to know the total cost from 8 to 12 players. Our domain is from 8 to 12. However, we need the range. They're asking us to find range, which is the value of y. So we need discrete information concerning y values. Well, that will eliminate A and B since they are continuous and also they start at 0. And we're not interested in starting at 0. We will start with a cost of 8 players. So we need 8 to 12 players. Well, look at C. It has 8, 9, 10, 11, 12. However, that is the domain. So we don't need C as an answer. We need C as a guide to find the Y values, which are our total costs. And that would be option D. Now let's verify those numbers using our calculator. Okay. All right. So this is what you can do. There are two ways to do this, but let's do it by adding table. So first we need to go up and see how it says y sub 1. And that's just a labeling thing because you can have several tables, but we don't want that. We just want just x. And then we go over here. Okay. You can use your mouse and place your cursor where you need, and then do a delete or a back button. Okay. And now we need to put in our actual equation or function. Okay. So let me push up what we can see. There you go. I've changed it where we can actually see the keyboard. Now let's put things in with our keyboard. So we have 4.95x plus 6.25. Now we have what we need entered and we can create our table. We do that by going over underneath our our x, and put in the numbers that we need. Well, I know that we need 8 and then 9. And it's intuitive. Again, that's one thing about Desmos that I like. It's already saying, hey, you need 10. And just enter, and it goes 12. And then it goes consecutively, and those are the values that we need to check. So we look at our D option, and we see that each of these values can be verified. Therefore, option D, again, is correct and verified. Thank you for watching. If you would like the materials that accompany these videos, you can visit us at numbersareradical.com. And once again, everyone, happy testing.